Hello everyone. This is your geometry teacher. I'll be filming just the one problem related to what we're learning right now. It's about the perpendicular lines having -1 as the result of multiplying their slopes. When two slopes have reciprocal slopes and they when you multiply their slopes, it becomes -1. We'll see how that happens, okay? All right, so first of all, let's briefly go over what slopes are. What is slope, okay? So what do we call slope by, okay? Basically, everyone knows, a lot of students tell me that it's a line. Okay, so we all know it's something related to a line. Okay, but what about line? What is it about a line? Line is not a slope. Okay, why don't we just then call it a line instead of slope? If those two are the same things, we don't need two words for the same thing. So it has to be something about a line. But what would it be, right? Some students tell me, okay, rise over run. Some students tell me it's rise over run. It's, from their memory, from like 7th grade, 6th grade, they remember that learning about slope was something related to rise over run. If you remember, right, rise refers to the vertical difference, the difference in measurement in terms of the height. So if you're looking at these 2 points, you're looking at this measurement. Let's say this is 1, because right now it's just 1 box different. So that will be your rise, because it's rising 1, and this will be your run. So this will be 1 in this case too, because it's only just 1 box. So in this case, it will be 1 over 1. So that is your slope, yeah? And that is correct. That will be how we give a numerical value to our slope. That will be a mathematical equation to get the numerical value for it. But in words, in literature, in our daily words, we call slope, as you can see, it's about how tilted is your line, what kind of angle does it have? How tilted is it, okay? So that will be your slope. And then we do have numerical values to determine how much it has tilted, which is basically governed by this equation, which is rise over run, okay? All right, so that was a quick review on the slope. Now let's get into our core main lesson, okay? Having -1 as a multiplication. All right, so first of all, let's find out the slope for this line. Whenever you find the slope for a line, remember, a line is a collection of infinite number of points. There are so many points on this line right now. It's just, it happens to look like a line because we have so many points and we just happen to connect them so that it becomes like bolded, right? So there are so many points and you just need to pick 2 points, okay? So for example, I'm gonna pick this point and then I'm gonna pick this point. Okay, you know what? Let me just pick this point. To make my life easier, because it's right at where the box's grids are, it gives me the clear measurements, right? Okay, so as we said, it's rise over run, right? I chose this point. So rise is 1, run is 1, so I know it's 1 over 1 is 1. For example, let's say I chose different point. I chose this point, which is right here, and I chose this point. So let's say I chose this point and this point. What's the difference? What's the rise? 1, 2, 3. What's the run? 1, 2, 3. So 3 over 3 is 1. You can see that it's the same. It doesn't matter which points you choose, right? As long as you choose the 2 points on the line, it will have its slope the same because it's tilted the same amount, right? It doesn't matter which points on the line, okay? That's the characteristic of the slope. Okay, so now we know how to find the slope, okay? All right, so one thing we said about perpendicular is perpendicular is when you have exactly cross relationship. When your angle says 90 degrees. It means when it's exactly crossed, right? And if you think about it very quickly, right now it's rise over run for slope, right? If you want something to go cross to this original line to make 90 degrees, okay? You can kind of see that the slope for this line and this line is opposite. It is in an opposite relationship. You can see that. It's rise over run for this line. So then it will be rise over run for this line as well. It's just that for this line, it happens to be that it's not a rise, but it's a drop. So it's drop over rise, but we could just term drop as negative rise, right? So it's the same thing, rise over run. But you can see that it's exactly the same as this line, but it's just in a different direction. Yeah, you can see that, right? It's going up, but it's going down. But you can see the tiltedness is exactly the opposite because how it's exactly 90 degrees, how it's crossed. So there you can see, briefly, why would they have, if their slopes get multiplied, why would they have -1? Because let's say this M1, let's say for example, it was 2 over 3. It was rise was 2, and then the run was 3. Then for this one, for the opposite, the line that's crossing, must have this as its slope. But if you see, and that's why it becomes -1. If you see it, it just means that, right? Its rise became its run, and its run became its rise. And then they just switched the sign to tell you that the direction has changed. So, in words, you can also see why this makes sense. And in diagram, in the graph, you can also see why it makes sense. All right. Now let's now that we cover that, let's see if you understood. That was a lot. So don't be don't panic if you don't know how to do it. If you don't get what I'm saying, that's okay. All right. Okay. So just to kind of go over quickly, perpendicular line concept. I want to show you in real life what will be considered perpendicular. So all these things, right? Like the basketball court. You see all these perpendicular lines like around the court, right? These are all perpendicular, right? Tennis court, you see the perpendicular line, right? If you go to the Google Maps, this is a Los Angeles map. Let's zoom in, and you can see mostly our road construction, how it's arranged in America is we have a lot of perpendicular roads, right? Most are literally perpendicular, right? Like a chessboard. Okay. All right. So now this is your question. Okay. I want you to see if you can say, is line number 1 and line number 2, do they have perpendicular relationship? Are they perpendicular relationship? The answer should be yes or no. And then your reasoning is required. Okay, your reasoning probably should involve your calculation for slopes for both of the lines, and then coming up with multiplication of those two lines slopes so that you make them equal to -1. Does it equal to -1? If it does, then it means the slopes are perpendicular. The lines are perpendicular, indeed. But if it's not -1, if the slopes multiplication do not equal to -1, that means you don't have 90 degrees perpendicular lines. Okay? All right. Good job, guys. See you next time.